Okay, now we're going to look at the other side of the paper where it's multiplying and dividing scientific notation. So you want to read this, and it says multiply and divide the numbers. Use the product rule or quotient rule to change the exponent. Use Lars again, so that's that if the number goes to the left, then we add. Or if it goes to the right, if we want to move the decimal to the right, then we subtract. So move the decimal to the left is add to the exponent, and move the decimal to the right is subtract from the exponent. To shift the decimal and change the exponent to the final answer if needed. So on these, what you need to do first of all, so these work kind of similar to other things we've talked about with exponents. With multiplying, you add. When you're multiplying, you'll add the exponent together on each one of them. So first of all, we're just going to multiply the two coefficients. So 2.8 times 1.9. So 2.8 times 1.9 is 5.32. And it's okay if you use the calculator to do the multiplication part. And then it's just going to be times 10 to the, and then we're just going to add these. So it would be 7 and 4, which is 11. So the answer is going to be 5.32 times 10 to the 11th on that one. The next one, again, what we want to do is multiply our coefficients. So 1.3 times 4.7 is 6.11, and then we want to add 9 plus a negative 5, so that's just going to, in the end, be 9 to the 4th. And that's how we would do that problem. Okay, the next one, again, we're going to multiply our coefficients because we're still multiplying right here. Pay attention to your signs. But we have 3.4 times 8.5 is 28.9. And then we want to add a negative 2 plus 6, which is 10 to the 4th. But we have a problem here because whenever we are in scientific notation, we only want to have one number before our decimal. So that means we need to move this decimal one spot to the left, which when we follow this rule up here, if we move it one to the left, we add to the exponent. So in the end, it will be 2.89. I'm going to add one more to it because I moved it one to the left, so it will be 2.89 times 10 to the 5th power on that one, and that's how we do number 3. So let's look at number 4 on here, and it's 2.5 times 7.5 equals 18.75. And then it would be times, and then we have 11 plus 10, which would be 10 to the 21st. But again, we have this problem that we have 2 digits here and we can only have 1. So again, I'm moving it 1 to the left, which means I have to add 1 to my exponent. So I have 1.875 times 10 to the 22nd. And that is how you would do number 4. So let's try number 5. So again, I have 3.7 times 5.6 equals 20.72. And then I have a negative 2 plus a negative 3, which negative 2 plus negative 3 would be negative 5, 10 to the negative 5th. But again, I have to move it 1 over. So that means I'm going to add 1 positive to that. So then it's going to be 2.072 times 10. So negative 5, but plus 1 is 10 to the negative 4th on that one. And that's how you do number 5. number 6 on here is 1.64 times 3.5, which is 5.74. And then if I add my exponents, I have negative 24 plus 27, which would be 3 in the end. So it's going to be 5.74 times 10 to the third on number 6. Okay, the next ones are division. So in division, it's the same thing, except for remember when we would divide exponents before, like say if we had 10 to the fourth divided by 10 to the second, we would subtract them. That's the same thing we are doing on these ones. We are taking the first one, the first exponent, and subtracting the second one. So, but we are, again, and then we are also dividing these numbers. So if I have 3.72 divided by 1.2 is 3.1. And then if I have 10 subtract 5, that's going to be times, or 8 subtract 5, sorry, that's going to be 10 to the third. So that's how you would do number 7. Then next, we're going to take the 6.4 and divide it by 4.0, which is 1.6. And then I have negative 4 subtract 6, which would be negative 10. So it's times 10 to the negative 10th. And that's how you would do number 8. Then next, 4.5 divided by 1.8 equals 2.5. And then I have a 3, and then subtract a negative 7. Well, remember when I subtract a negative, it's really positive. So that's going to be 2.5 times 10 to the, this will end up being 3 plus 7, which is 10. So that is that problem. Then on number 10, we have 2.1 divided by 2.8 equals 0.75. And I have a 7 and a 3, so 7 subtract 3 is 4, so I have times 10 to the fourth, but I have a problem that I need to have just one number on the left side of the decimal. So I need to move my decimal 1 to the right, which means I need to subtract 1 from here. So then it's going to be 7.5 times 10 to the third on that problem. And number 11, shows I have 2.7 divided by 2.4 equals 11.25. And then I have negative 5 subtract a negative 6, which right now would be 10 to the negative 11th. But again, I have this problem that I have 2 digits to the left and I just need 1. So I need to move my decimal over 1 to the left, which means I will add a positive 1 to my exponents. And I have 1.125 times 10 to the negative 11 plus 1 is negative 10. Oh, actually, let me back up on this one because I forgot when I am subtracting a negative 6, it's going to be plus 6. So negative 5 plus 6 on this one is 10 to the first. And then, so then if I have, and then I needed to add one more to it. So then it would be 1.125 times 10 to the second on that one. And then on this last one, 2.0 divided by 3.2 equals 0.625. And then if I have a 6 and then subtract a -7, so that's adding and 7. So 6 plus 7 is times 10 to the 13th. But then I also need to move up my decimal over 1, so that means subtract 1 from here. So it's going to be 6.25 times 10 to the 12th. And that is number 12.